Hello, I'm doing a series of videos on Variety Slitherlink. This one is on the Snub-square tiling. There are a lot of tips in the prior videos you may want to check out, but just to quickly review, in the finished puzzle I'll be drawing a path. The path goes all around the puzzle and eventually meets up with itself, making a loop. The loop has an inside and an outside. The clues on the squares, on the cells, I should say, they're not all squares, tell you how many of the outer edges are set. So on this 0 cell, none of the outer edges on that 0 are set. On this 1, which is inside of a triangle, just one of them is set. On this 3, 3 of them are set, and so on. So let's solve this puzzle here. Now I should point out that on these snub square puzzles you have both triangles and squares. The regular patterns you may have learned on classic Slitherlink work sometimes, but they don't work the same way on triangles. In prior videos I've, pardon the dog, in prior videos I've talked about the concept of max squares, which are, or I should say max cells, which are cells that have clues that are the maximum possible value for that cell, which is one less than the number of sides. So here I have 2 max cells. When you, the 2 that's inside of a triangle and the 3 that's inside of a square. I'm going to pause here a sec to let the dog finish. So in a regular Slitherlink, if you have 3s that are touching, there are certain things you know how to do, or you may know how to do if you've done a lot of those puzzles. But the general rule for max cells is that if they share an element, like an edge, you set the shared element if you can. You eliminate any paths coming out of the shared element that don't go into the cells, and then you set any edges that don't touch the shared element. So that's what you do with a 2 and a 3. There's a similar situation here where I can eliminate these escaping edges on the 2 and the 3 here. Any more of these? That's a 2 and a 3, but the 2 is inside of a 4-sided cell, so it's not a max cell. There might be a 3 and a 3, or two triangle 2s. Or any of those? I don't see any. Here's 2 3s. These are both max cells, so I can set the opposite edges and then clear the escape path. Moreover, they're next to some 0s. The 0s, of course, are easy to cancel out, and then we can complete these 3s. So we made a good bit of progress on that area. Here's another 0. As I go around looking for max cells, I'm also just going to clear out any 0s I encounter. All the intersections on this snub square tiling have 5 lines, which makes the dealing with the intersections a little harder. Whoop, I meant to cancel that out. There we go. But the triangles make things a little easier in some cases once you get used to them. Okay, we can complete this one. This path is forced. This line, which goes into a max cell, can't escape it, because if it did, you wouldn't be able to complete it. So you can eliminate the escape path for any lines going into max cells so that the path can't bounce off of them. So this line will come in here, use one of those 2 cells. This one is completed. This 2, which is just a simple triangle. Now that we've eliminated one piece of it, we can eliminate the rest of it. This line is forced to go into this 1, so we can eliminate the opposite edge, and that now forces this line to go into that 1, eliminating that edge. We've got a corner on 2 1s, so we can set the opposite edges on those. This 1 has been completed, so we can finish this 1 here. Complete the 3 and the 2. Complete this 1. We've got some 0s here. There's a man running a leaf blower or lawn mower outside my window. I apologize for the noise. I can't use these 2 edges. If I use this edge, it forces me to use a second edge on this one, so those are both not usable, so we'll use just the remaining usable edge on that. It's going into a max cell. It can't bounce off. I've got a 2 here which has an exposed corner. That means that the path is either going to go out like this or avoid the corner entirely like this. And apparently, and it can't do that because of the 0, so we're forced to use the outer edge. Even if it weren't forced to use the outer edge, it would have to escape out here. But we also know it can't go there, and it is in fact forced to go that way. We can't use both of these edges on this intersection because it would overcrowd the 1. So that means the 1 is completed like so. This one can also be completed. We're going to use one of these 2 edges on this one, so we can eliminate that edge. Got a 0 here I can't use, a 0 here that I can eliminate the edges of. Similar situation here with this 2. I don't know which of the 2 sides it's going to use, but it's going to use one of either this corner or the inner one, and then it'll come out here and use that 1, which will complete the 1. Therefore, it must use the outer corner. Then we'll use one of the 2 edges on this one, so I can clear the opposite edges. Clear all this, clear that. Now that I've eliminated all this, I can't use the upper edges on this 1 because I would be forced to use both. So this must be a border edge, as is this whole section. We're going to use one of these 2 edges, and then this one will be forced. So I can go ahead and begin to do a little coloring here on the shared stuff. I'm just extending the coloring through the canceled edges. That tells me that these are border cells. These are any cells. So we must be using that side of the 1. This 2 is in a corner, has an exposed corner here. It's got to come out the top there. That edge goes into a 3, so which is a max cell, so we can set the opposite edges on it. I have a line that's forced to go into a 2 inside of a 4 cell. Just as in classic Slitherlink, when a line is forced to go into a 2, a 4-sided 2, a line is forced to come out the opposite side to escape out. So that forces the use of this edge on the 1, and also takes care of that. So this is an edge, any cell, border cell on the edge. Those parts of the path are forced. I don't yet know if this is going to go up here and connect that way, or if it's going to go like that. Another 2 on with an exposed corner, so I can set that. This is again an edge going into a 2 here. It's going to be forced to come out here, and the edge that comes out won't be able to bounce off this 3, so I can eliminate that one. So we've got an edge coming into this 3, so we can set the opposites on it and clear out those guys. I'll go ahead and do a little more coloring. What I typically do when I'm not seeing any immediate choices. This 2 has to use at least one of these 2 edges, and that kind of forces this part of this 1 cell to be used. If it's using this edge, that edge gets used, and if it's only using this edge, then it's going to have to come out this way. And so we're using this half of this 1. which means we're not using that half of the 1. And now that I know that I'm using this half of the 1, I know it's got to escape out, which means this edge is forced. I can see, because this one has 2 neighbors of the same color, that it must be open to them, which means only this edge can be used. And that simplifies the coloring here and allows us to complete more of the pathing. We can complete this too. Now we've completed that one. Complete that. And this 0 section is connected. And this blue has to connect up here somehow. But I'm not sure how far this yellow goes, if it terminates here or further up. It just can't. But the yellow can't go all the way to here. But I guess it could terminate here, and then another yellow section could come out here. So I'm not sure how that would work, but I'm gonna leave it alone for now and look elsewhere. Well, so much for looking elsewhere. I was just noticing that this edge can't be clear like that, because if it were, then this would be closed off like that, and this would be illegal, and we would make a little island down here. So none of that can be true, which means this edge must be used, which doesn't buy us a lot. Sometimes I do very elaborate logic just to make a little bit of progress, and it's not always worth it. I can see that this is good. I can see that I can't use this edge, because if I did, it would put a corner on this too, and then I would have to use both of these edges, but this one's already been canceled. So that means this edge can't be used, which allows me to complete the 3 and the 2, and this 2. I can see at some point we're going to figure out the coloring on all these connected cells here, but I don't yet see it. I see a lot of spots where there's 2 choices that seem equally valid. Okay. I see that I can't use this edge, because if I did, it would make a little house shape, which would be an island. So that is cleared, which forces the outer edge on this too. Still not sure about the rest of it though. I can see that regardless of how I complete this 2, it must feed into the 1, so I can't be using that edge on the 1. And I can't be using any of these edges. This one must feed into this one, and there's only one place to go. Clearing the escapes from that corner. So there's still potentially a path coming through there. This edge can't be used because the remaining ones in its intersection are already ruled out. That rules out this edge here, and now this path is forced. That is forced. That rules out this. And We can't bounce off this 2 because I can't make a corner down here. Sorry for the noise. If it went like this, then I'd be forced to use this side of the 1 and it would have nowhere to go. So that can't be used. And I think we have a forced path on this 1. Can't use that. That finishes the 2. That is forced. And now we've made quite a bit of progress because we have colors on a big chunk of this. And we're going to be making tons of progress from all this. This is all connected. Connected around there. That's connected. We got an edge there, an edge there, there. There, there. Can't use both of those. So that finishes that 1. That's all. Finishes that 1. Finishes the 2.
Someone was detected at your front door.
Someone was detected at my front door, and it's probably a guy with a leaf blower. Complete that 1, complete the 2, and the path is forced. So a good bit of progress. We can't escape the 2 here, so we can clear both of these edges, set the opposite side. That makes this a any cell. Completes the 2. Whoop. There we go. That completes the 3. And I think we are very close to completing the puzzle at this point. That'll complete the 1, that'll complete that 1. This has to come out. So these are the 2 opposite sides, yellow sides of the 2. I can see that this 2 uses the outer corner or the inner corner, but it can't use the inner corner because then these 2 wouldn't be able to be opposite polarity, blue and yellow. So it's got to be like that. And then we've got an edge there. And then this has to come out like so. This has to connect. One of these 2 edges is open, which means these are both closed. I know that one of them has to be open because this is a blue neighbor and this is a yellow neighbor. It's outside. So one of them must be set. I just don't know which one yet. It's going to go like that. So I think these 2 sides of the puzzle are relatively independent at this point. So let's see what's going on here. Oh yeah, this is all connected due to the 0. I think I'm gonna have to escape out by this edge on the 1, which means I can't use that edge. So it's gotta go like that. And then we're going into this 3 like so. We can do some coloring. There we go. So that completes that side of the puzzle. I've got 3, this is another subtle one. I've got 3 lines here. This one can't connect to that one. It could connect to this one and then this could go back around, but somehow there needs to be a 4th line coming out. And of course I can also see that just due to the coloring. So this is the situation here. We complete the 3. And this yellow has to escape out to the edge because it's outy. So it does so like that. This is also yellow, and the puzzle is complete. Oh, that's a lovely picture. So that is a Snub-square Slitherlink. I'll be covering more of these variety tiles over the next few days. If you want to see others, see you then.